All right, pre-cal, we are going to work through these notes on inverse functions. So a few things, I expect you to be somewhat familiar with inverses from Algebra 2, but I'm going to teach it like you've never seen it, just a little bit faster. So first of all, an inverse function, they undo each other. One inverse function will undo the other one. So like we may think of, we kind of have been using them in solving equations for longer than we ever knew. So say I have something like 2x plus 1 equals 7. I don't know. We would undo these things to solve for x. So the opposite operation from addition is subtraction. So we would say, okay, well, 2x equals, subtract away the 1, we get 6. And then we would undo that multiplication here with division and say that x is equal to 3. Okay, so that's kind of what we mean when we talk about how they undo each other. So, getting started here, well, the next thing, the x and the y switch, and so the domain and the range switch. They also, inverse functions also have, they're reflected over the line y equals x, which in this case, I think, I think is roughly, pretend I can draw, something like that. So the new function should be, the inverse should be a reflection over that particular line. Now the next thing, the inverse of every function is not a function. So what happens here, let's look at this first one, and we'll explain that idea when we work through this first example. And then following through with that we can restrict the domain of a function so that the inverse will be a function. That will make sense when we work through number 1. And then this one, number f, this is the, if I ask for an algebraic proof, this is what I want you to do. I want you to show that f of g of x and g of f of x both equal x. And that's the algebraic proof to show that two functions are inverses. Okay, so let's look at a particular situation and see what is happening. So if I look at this, I see this piecewise function, and it's kind of gross. I mean, it's not that bad, but here we go. What I notice is that this is the point, 2, -1. This is the point 0, 0. This is the point, what is that? -3, positive, oh, no, that's gross. There, that is gross. -3, and what is that, 1.5? Yeah, we'll just say 1.5. That seems to go by 0.5, yes, okay. And then I see that I have the point 2, 4. And down here I have the point 4, 0, and over here I have the point 6, 4. And so the reason that I did this is that way when I want to go find the inverse, I just need to switch my x and my y. So now instead of the point -3, 1.5, I need the point 1.5. 1.5 is going to be somewhere on here, -3, which is down here, and it would still be a closed circle. And now the next thing, let me make sure I agree with what I just did. This is 1.5, and then here's 1, 2, 3. Super, okay. The next thing, 0, 0 is still going to be 0, 0, because I switched 0, and 0, 0 switched is 0, 0. And now instead of the point 2, -1, I now have the point -1, positive 2, and this one here has an open circle. Okay, so this little piece right here, oh, that's a pretty straight line. That's shocking. That little piece right here has this piece here has reflected over that line y equals x, and it looks something like that. Okay, continuing on. Then we need the point, instead of the point 2, 4, I now want the point 4, 2, which is going to be here, and this is a closed circle. And then I need the point, instead of 4, 0, I now need the point 0, 4. That's going to be here, and this is, that was weird. That's a close point. And now instead of the point 6, 4, I now want the point 4, 6. 4, 6 is over here, and this is an open circle. And so you'll notice, let's see if I can draw something that sort of resembles a sideways parabola. Okay-ish, whatever. Notice our original function is a function. So the question is this one a function? The answer is yes. Then we ask the question, is this a function? And we would say, no, it's not. Notice right through here, well, actually, there were a few places where I failed a vertical line test. I failed it, like right in here. I've got 1, 2, 3 values that have the same, they have the same x value but different y values. So this one is absolutely not a function, or it's, undo. The inverse is not a function. Well, so cool. We've answered the question. We sketched the inverse of the following function. The inverse was not a function, but to be honest with you, that's not very helpful. So what we're going to find that we need to do is when we have a function whose inverse is not a function, we as mathematicians agreed to restrict the domain of the original so that its inverse is a function. So let me talk through, well, okay, I'm going to skip some of this for a second, and then there's the worksheet, but let me, what's it doing? Okay, there we go. I needed more space. So for example, what we'll do is if we have the graph y equals x squared, what I'll do, not just me, what we will do as mathematicians is we'll come in here and say, well, notice if I were to find the inverse of that, I'm going to end up with something like this. Well, this in red is not a function. Notice how that fails the vertical line test. So what we'll do is we'll say, well, let's just take the positive side, and if we were in my classroom, I'd be raising up my arms to make a U shape, and then I'd be cutting off one arm, and so I just have one arm up, and it looks something like this. We're going to take just this part. We're going to restrict the domain. We're going to restrict that to 0 to infinity. And so now when I find the inverse of that, now I end up with this right here. Pretend I can draw. And this is a function. Okay, so what we can do, thinking about this, is that I take my x and my y and I switch them. So now x is equal to y squared. And technically, when we solve this, we do the cheer, square root, plus minus. And so we could say that this plus or minus the square root of x is equal to y, but the plus or minus the square root of x gives us both the top and the bottom part. Here's the plus, square root of x, y is equal to that. This is the bottom with the negative. The negative is the bottom. But that's not a function, so that's no good. What we will say is that, let me come back again, I'm sorry. If this had been f of x, to say, we can say okay, here's how the notation works. The inverse is a little dash line right there. The inverse of y, okay, this is y was x squared. The inverse of y, or we could call it f of x, is equal to x squared. This is equal to plus or minus the square root of x because I need both sides of that in order to really find the entire inverse of that. However, that's not helpful. What we will typically do is we'll use the inverse function. So as soon as I use function notation, I have to have a function written here. This, because of that negative, plus or minus, not because of the negative, but because of the plus or minus, it's not a function. So what we'll say is that that the inverse function will just be the positive square root of x. Okay, the other part was that the inverse of f of x would be equal to, this would be saying something squared. What's the something? The square root of x. The square root of x squared is just giving us x. Or I could say the inverse of f of x would mean, okay, take the square root, what goes inside f, which is x squared, which gives me also x. And this, ladies and gentlemen, is that algebraic proof that those are inverse functions. Let me look back. I think I want to work through these in the next video. So that's kind of the introduction to inverses. I may actually have a video over some of these from previous years. That would be awesome. Good luck. Go practice. Go find the next videos, and I'll see you later.